Okay, so another no calculator, just evaluating a definite integral. If that's the case, either you're drawing a picture and finding area from geometry formulas, or you have to use a fundamental theorem. We're not going to have any luck graphing the square root of x times x plus 1 and finding, rigid geometric shapes to find area. So this must be a fundamental theorem question. How do we find the fundamental theorem? How do we find an antiderivative of this? First of all, don't try to take the antiderivative of root x and then times it by the antiderivative x plus 1. That's not going to work. The trick in this problem is you need to distribute. Well, first, think of this as x to the 1/2. And then distribute. And when you distribute, it looks like this. So it's x to the 1/2 times x to the 1, which is x to the 3/2, plus x to the 1/2 times 1 is x to the 1/2. Now I can just undo the power rule. Okay, just undo the power rule. Okay, that is the trick to this problem. All right, so antiderivative here would be, so I'm going to add 1 to the exponent there, so that becomes x to the 5/2, and then I need to cancel it with 2/5, plus the antiderivative of x to the 1/2, so that becomes x to the 3/2, but then I need to cancel it with the 2/3. And now, nice thing is when we plug in 0, the expression vanishes, right? Because they're just x's, which will turn into 0. So this ends up just being 2/5, 1 to the 5/2, plus 2/3, 1 to the 3/2, minus, now I'm just going to get 0 when I plug it in, so I might just anticipate that. 1 to the anything there is 1. And then I get this. So now I just add these fractions. So 2/5 is the same as 6/15, and 2/3 is the same as 10/16. So that's 10/15. So I get 16/15, which is answer choice C.